All right, so we did electric fields, we did potentials and potential difference, and we related to the electric fields, right? And we did a little bit about the flux, and we saw how those things are connected to the electric field. We saw how the electric field is connected to the potential difference and the distance in a uniform field, correct?
Yes.
And I said electric field is a negative of the potential gradient. So that concept can be used in some of those problems that you solve, that the potential, the field is going this way, and the potential over here is something. What is the potential over here? Or anywhere. So if the field is going this way and they give you this potential should be higher or lower?
Higher.
Higher. And if they tell you the field is so many volt per meter, then you just go by how many meters are there till this part, and then you just go higher and higher by the same amount. If it says 100 volt per meter, then from this part, after 1 meter here, it's going to be 100 more, 200 more, 300 more. So how many meters you go, it's going to be higher and higher. And if you go the other side, it's going to go lower and lower. Okay, so those are little concepts that you should know. The next one is capacitance. Capacitance of capacitors. Capacitance of capacitors. So what is a capacitor? A capacitor is typically two metallic plates separated by a distance. Two plates separated by a distance. Of course, the distance is not going to be as big as this. The distance is normally very, very small, and the plates are going to be extremely large. So a capacitor is that. What is the purpose of a capacitor? Capacity means it's the capacity of holding charges. It's a capacitor is basically something that can hold charges for you. Okay. So how can it hold charges, and what is this process of charging? The process of charging is simple. You connect a battery. If you connect a battery of, let's say, 12 volts, if I'm connecting a battery of 12 volts over there, positive here and negative here, this plate on the top here is connected to this terminal. What does plus sign mean?
Positive.
Yeah, positive means?
That means that's where the...
What is actually the meaning of positive and negative? Positive means?
lack of electrons.
Deficiency in electrons, right? So what happens is as soon as you connect this terminal here, the electrons from here are going to go there. So it's going to be creating the deficiency here. So it will create deficiency here by that action. Okay, make sense? So once it creates a deficiency here, we call it, yeah, it's getting charged. It creates a deficiency. Now, because this plate and this plate are so close together, because there's a positive sign, and this has got excess electrons here, right, the battery. So what will happen to these electrons which are sitting here, ready to go, and here there's a need because that's positive and this is trying to pull opposite charges close to it. So these electrons will run down here and charge this plate negatively. Now this process is actually called charging. Charging the capacitor. Now since there is nothing in the path, charging like this is going to be instantaneous. You connect, it's charged. You just connect it and it's already charged. So when is this charge going to stop? Like, when is it going to stop? Is it going to continue, go on charging? When is the process going to stop? So let's say again, some positive charge comes here, some negative charges come here, right? So when there's a positive charge and a negative charge, is there a potential difference between those two? Yes. Previously, there was no potential difference across the capacitor because it was uncharged. The two plates were just uncharged, neutral. So there's no potential difference. But when this became a little positive and when this became a little negative, what happens is there is a potential difference building up. You are building up a potential difference. And remember, this potential difference that you're building up is in the opposite direction to that one. You see it? This is plus here, minus here. So trying to make a current go that way. It's trying to push a current that way. Whereas this becomes positive and negative, acts like a battery. And this is trying to push current which way? That way. Obviously, that voltage is much more than what you have here, maybe 1 volt, 2 volt. So what's the net potential difference now? That's 12 and that's 2 volts. What's the net potential difference? 10. So can the charging go on? Yeah. So therefore, the next positive charge comes here and next negative charge comes here. Increases the potential difference from here to a step higher, maybe 4 volts. Still there is 8 volt difference. So the charging process will go on continuously. And at one point it will be 11.9 volts here, and that is 12 volts. Still there is some room. And finally, when the potential difference over here reaches exactly what you applied there, 12 volts, this is 12 volts, positive, negative, trying to push current this way. This is 12 volts, equal to that, positive, negative, trying to current. So what is the net potential difference? Charging stops. Charging process is over. So when will the charging process be over? When the capacitor builds up enough charges to create a potential difference between the plates, which is equal to that. Get it? Yeah.
When did the battery lose charge to?
What do you mean battery? Battery is a chemical generator. It's going to generate. 12 volts is its EMF, so it will keep pushing it. It is a generator. It's not like another capacitor. We'll talk about that later. But it is a generator. It's not going to diminish in 12 volts. Yeah, eventually, after a lot of usage, the battery will struggle to do this. Okay, so the effectiveness of this will come down. That's mainly because of the internal resistance that's building up. So if the battery is actually going down, it's mainly because the internal resistance is shooting up. So what will happen when the internal resistance shoots up? This process will be slowed down. Can the current be the same old current if some resistance is there in series? No, it will slow down. Yes, will it charge to 12 volts? Yes, it will. But it will be a slower process, not quick. If I put a resistance deliberately here, this charging will go on, but slow. But eventually it will reach there. So this capacitor is now fully charged. At this time, if I remove the battery, the charge is sitting here. There is some charge sitting here. And the potential difference built is V. How much charge builds up depends on how many volts you're offering to it, right? So when only the 1 plus and 1 minus came in, the charge is small and the potential difference was also small. When more and more charges came in, this also was going up. So for a capacitor, the Q that is building up is proportional to V. So when you apply 1 volt, it's only a little charge. When you apply 2 volts, it's more charge. It goes directly proportional. Graphically, QV, a straight line. Q is proportional to V and is a straight line. Now all capacitors will behave like this. Q is proportional to V is going to be true for all capacitors. But the slope of this line is not necessarily going to be the same thing. Like for example, if I have another capacitor, if I put 1 volt over here, it's collecting some charges, right? Let's say it collected 10 microcoulombs when I put 1 volt. When I put the same 1 volt over here, this probably is going to take up only a small charge, let's say 3 microcoulombs. Okay, so this capacitor, 3 microcoulomb is all it gets for 1 volt applied. This one can take up 10 microcoulombs for that volt. So Q is proportional to V, and the slope is going to be different for different capacitors. It makes sense? This one has the smaller slope. That one has a larger slope. Yeah.
Is it just the distance between the plates that matters? Or?
That is one factor. There are so many factors, we'll see it soon. There are so many factors which takes care of the capacity. How much is the capacity? So this equation is written as Q is equal to CV, where C is the constant of proportionality. C is the constant of proportionality. See, I removed the proportional sign and put an equal to sign. So this is the constant of proportionality. Called capacitance. That's called the capacitance of the capacitor. So essentially what? C is going to be Q over V, which simply means how many coulombs can it hold per volt. For 1 volt, how many coulombs can it hold? For 1 volt, how many coulombs can it hold? For 1 volt, how many coulombs can it hold? That is what is known as a capacitance. So what is the unit of capacitance? It's coulomb per volt. There's a lot of confusions can come using the same symbol. Coulomb per volt. Let me write it like that. It is coulomb per volt. And instead of writing coulombs per volt, because both of them are derived units, right? Both are derived units. Instead of writing all this all the time for capacitance, we use one word, farad. Farad. Farad is a unit of capacitance. Farad is a unit of capacitance, which is basically coulomb per volt. So try to get that connection. Farad is a unit of capacitance, and 1 farad is a big capacitance. 1 farad is a big capacitance. So normally we measure charges in millicoulomb, microcoulomb, nanocoulombs, right? So also the capacitance will be in microcoulombs, nanocoulombs, picocoulombs. Sorry, nanofarads, picofarads, microfarads. So normally used unit or commonly used unit is microfarad. The capital F as a unit is farad. It is the first part of Faraday. Because Faraday has contributed a lot of stuff to electric fields and all that. So farad, microfarad. Now, capacitors need not look like that. It can be in different forms. Here's a capacitor. It's a cylindrical format. So what they've done is, they took this, those two are two aluminum foils, and they put a wax paper inside. They put a wax paper inside so that these two don't touch. And after that, they just roll it. Capacitor. Right? You see it? And then they pull out one wire from one of the plates, and they pull out the other wire, sometimes from this end, sometimes from the same end. Here it's pulled out from the same end. And that is a capacitor. And you can read what is on this. It says 470 microfarads and 200 volt. That means like it can charge up to 200 volt. So if I charge this up to 200 volts and leave it here, and you think, oh, it's capacitor. You can get a big shock because 200 volts is right there, waiting. That's why, capacitors on a circuit board is very dangerous. You can't just handle those boards straight away. If you want to do any testing or anything like that, if you're touching the board, there are some areas of the board mentioned hot, and some areas of the board says cold. Cold means like it's a voltage which is smaller, like 10, 12, 13, 14, 15. It's not going to give you a shock, but the hot area can go up to 500 volts. Big shocks possible. Now this is a 200 microfarad capacitor, and it says it can go up to 105 degrees Celsius and still perform fine. The 200 is a maximum. If you apply more than 200 to this, it'll explode. Don't say try it out, no. So if I put more than 200 volts over here, it's going to explode into pieces. Now, see, this is another capacitor. That's another capacitor. And this one says 1000 microfarad. Now this is only 470 microfarad capacity to hold. But this is 1000 microfarad. Look at the size. What's the other difference? The voltage, 16 volts. It can't take more than 16 volts. And if you do apply more than 16 volts, there will be ionization taking place to that paper that you put in. So there will be ionization and sparks running across, and it will cause burning and cannot withstand all those gases that are formed inside, so it explodes. Okay. If you want really, yes, you can try. But can you see this? In order that it does not explode in all the directions, at this side over here, you can see that the plate that is used has got some grooves on it. And that's a place where it actually opens up. So to release the gases, it opens up. So normally on a circuit board that is not working, that's the first thing I look for. Oh, is there anything that is opened up? That means it's a bad capacitor. And if I see something like that opened up, job is simple. That board, that television, when the student said it's not working and he gave it up here. So when I'm just always looking for this. Big mistake is this one. If this is fixable, if this is there, no worries at all. It can be easily fixed. But if everything like this is looking good, then I suspect the diodes, I suspect the transistors, and step by step. And if all those components are going to be more expensive than the board itself, then I buy the board. The campus store had a TV that the administration sent an email saying, we heard that you fix TVs and stuff like that. You want? Can you take a look at a campus store TV is dead. So I looked at it and I looked at the TV there and I said, yeah, it should be fine. And what happened? Some surge. Okay, during a storm, it went off. So I said, okay, then I can't climb and get it. So get it here and then I'll try. So I got it here and I found there's nothing that I can visibly see that is wrong. So then my suspicion came, because it's a power surge, suspicion was on the board, power board. So when I tested all that power board part of it, I was getting a shock at one point, yeah. But I tested all the power board and I found that everything is working fine, but then there are some components, some places that there's no voltage coming through. So I suspected that maybe the power board is gone. So instead of looking at the components, I looked up online. I got a power board for $8. I said, what do I want to, I don't want to spend hours on it looking for the fault. Ordered that power board, came, and I replaced it, no sign of any life. So the power board was okay, probably. Then the other board was a motherboard where actually it processes all the information from the remote control and everything. So it's a motherboard which has got some memory chips and all that inside. Mistakes can happen there, and all the video signals, HDMI cables and all the video signals are going there. So if any power surge comes, that is also a likely place for attack. So then my suspicion went to that one. I looked up online again, because normally those boards are $35, $40. I looked up online again, and luckily there was one person selling it for some price. like $10, $12. And then I said, and plus make an offer. Already ready to give an offer. I said, oh, offer. Then I looked at all the instructions. It said it was removed from a TV that had broken screen. Okay, then in that case it should be fine. If it's already working and the screen is broken, that's a good way to do it. Take out the boards and sell it separately. So I put an offer. I said, give me for $8. And he said, take it. Whoa, okay. Then after he says accepted, then I have to buy it. Anyway, I bought it. That one came 2 days back. I took it there, put it there, TV back to life. So that was the only thing. I didn't spend much there, and the TV came back, and now they've taken it and they already fixed it there. So feel good when you can revive something like that from that state to that state. Yeah. So first thing I look for is capacitors. So on this television, there were 6 or 7 capacitors which were like opened up, burned. So I knew that the culprit is right there. Nothing else could have potentially gone wrong. And so what I did was I looked at all my spare parts and I got capacitors. Now the capacitors that were blown were like 16 volt capacitors, bigger ones, but 16 volt. And some of them were 25 volts. So what I did was I found a replacement for the same capacity, but higher voltage than what is there. Apparently what's happening is Samsung TV has the same complaint. This particular TV has the same complaint. Many people have suffered this. And that's because there's a manufacturing defect. They have put a capacitor of a voltage which is very close to the maximum. That should never be the case. If you're reaching up to 16 volts, don't put a 16 volt capacitor, because there could be a little surge and boom, it can actually like break up.
That's how they get you to buy their product more.
What's that?
That's how they get you to buy their product.
Yeah, I know, but that is, it's a very common thing. This is the first time I did it. Second time I did was exactly same complaint. Mr. Wonderland brought his TV, and when I opened it up, I saw the same stuff. I said, 20 minutes will be done. And he was like, really? And I looked for the parts. And of course, when I'm putting the parts, I put a part which is better capacity, not capacity, same capacity, but better voltage. So this one can burn up or blow up at 16 volts, but I put something there which is 25 volts, higher voltage. How many years back I put that? It's working fine. No more blowing of those capacitors. So that was the only complaint. So this capacity is 1000 microfarads, but it can't take more than 16 volts. So you need to understand that also. So why is it that this can take a lot of capacity, but this one is only 470? It's because this can tolerate more voltage, this cannot. You understand? That's why. So you have big capacitors and small capacitors. This is a cylindrical capacitor, which is exactly this. That's how they do it. And we'll talk about that more about cylindrical capacitors. Now, and right now, the capacitors are charged to whatever voltage that you applied, and then it's waiting to be discharged. How do you discharge it? Just bring the terminals together. When you join the two terminals together, all this charge is going to suddenly discharge. And that sudden discharge is definitely going to be like, there is going to be two contacts like this, right? If we're going to use two contacts, if I touch it like that, at the point I touch, there'll be a big current. And before even I touch, the field will be so strong, it'll ionize the air right in that gap and make a spark. So it'll actually create a spark. Okay, and sometimes it can be so bad. So if it is charged to 200 volts and I leave it like that, if somebody comes and touches it, it's going to be dangerous. So what I do when I look at the board, before I test it or before I pull it out, accidentally I can touch it. Okay, sometimes I touch under the board and there is a terminal waiting for you. So best thing I do is I take a screwdriver or something like that. So this part is insulated. I just touch the two terminals like this. When I touch the two terminals like that, I am discharging it. So you'll hear a kind of bang, but it'll be done. Once it's discharged, you can touch it freely. Absolutely no problem. So that is called discharging. And if you discharge it slowly, you can't hear a sound and all that. Suppose I put a resistor here while discharging, it's going to be a slow process. Okay? So you won't hear a bang. But if it is a fast process, then of course you'll hear a big bang. Okay, I'll show that right now to you.
Oh, you wouldn't. He was. You're a bad man.
Let's see. I wish I could draw a hat on them, but it's too late. It's too high up.
Has he put it on page yet?
Yeah, that's what I thought.
could drop two Capacitors or songs
No. Here, I'll give this guy.
He just hasn't put it on our page.
Ooh.
Father seeing.
Don, no case.
Baja.
Oh, yeah.
Yeah, it's a capacitor. Now this one's capacity
That's a big mama.
this one's capacity is 2,200 microfarads,
Ooh.
and it can take up to 250 volts. That's its capacity. So I'm going to connect it to. Yeah,
Let's charge this crap up.
these is
Doesn't have much capacitors.
different circuits use it. Actually, I picked up this one when we made a field trip to AT&T.
AT&T?
Yeah.
They just gave you capacity.
Yeah, they gave some other dead capacitors too, but
Can I touch it?
is it on? Now I'll show you this in a moment, but I'm supposed to wear goggles. Let me see.
Nah, come on, man. You're crazy.
I've done this so many times without goggles, but I'm recording. I don't want this to go somewhere.
Yo, he's a snack.
I've done so many times without goggles standing right there.
Already know I want to love you. All you do is play Madden Mobile. You are a Madden Mobile fiend. Nobody plays Candy Crush.
There we go.
Oh, yeah. Here we go.
I'm going to put.
Somebody get this for the ground.
I'm going to connect it to plus power. This is a positive sign that goes here. Negative sign goes to the ground. So I'm going to connect it to 200 volts right now.
Heard you wouldn't.
I'm trying to make sure that I'm not touching anything here. All right, there we go. It is charging.
Uh-oh.
It's already charged. I'm just keeping it there so that it'll be steady. Oh, my goggles.
Come on.
All right, ready? I'm discharging it right now. It's charging, and now it is discharging.
Oh, damn! God, dude. Your boy jumped.
Again.
Let's see.
Yo. Yo.
Can we show